Now let's take a look at another way to find derivatives of different functions. So now we're going to find the derivative of functions that are we call composite functions. All right, remember, a composite function is when you have one function, one or more function, inside of another function. And all trigonometric functions are composite functions. You know, like sine of x. That is a composite function where your inside function, your g of x, so to speak, is x, and your f of x is sine. So in this set of notes, it is extremely important to be able to figure out and to find what your outside function and your inside functions are. Remember, there can be more than one inside function, meaning you could have the sine of the cosine of the sine of x squared minus 4. So you'd have several functions to have to figure out what their derivatives are and use the chain rule over and over and over and over again. And the last problem that we do, we're going to do that where we have to use the chain rule a few times. So first of all, you have to know what the chain rule is. So here it is. So f of g, you have one function inside the other. All right, it's basically you take the derivative of the inside right here, so that would be your g of x, your g prime of x, times the derivative of the outside, leave the inside alone. So I kind of say, find the derivative of the baby, or find the derivative of the mom, leave the baby alone, times the derivative of the baby. The baby is the inside function. Okay, I know this seems confusing, but the best way to understand something is through an example. And then first of all, before I go to the example, sometimes this is also called the outside-inside rule, where you find the derivative of the outside times the derivative of the inside. So you notice you leave the inside here, okay, leave that alone. Leave it alone. Let's do an example. Start with a simpler example. So the inside function, come on, get rid of this, there we go. The inside function you can designate as whatever variable you want, however you want to do it. But later on we're going to learn to use u substitution, which is kind of opposite of what we're doing here. So we're going to use u. So we're going to just make this simple substitution and substitute 7 minus 5x in for u. So then if you go back to the derivatives, for the chain rule, the derivative of this, the derivative dy over dx is just the derivative of sine is cosine. So it's just cosine of u times du, or u prime, whatever you want to put there. Doesn't matter. Okay, now we can go ahead and make our substitutions, but before we do that, we need to figure out what the derivative of this is, and that's just negative 5. And so then the derivative of this original function is cosine of u. Remember, the inside function stayed the same. It did not change. Times the derivative of the inside, the derivative of 7 minus 5x is just negative 5. Okay, and you can write that as negative 5 cosine 7 minus 5x. And then that is your derivative of this function. Alright, so you can use u to substitute that. You can use whatever variable. You can use f of x and g of x. Doesn't really matter. But like I said, we're using u because later on in the year we're going to learn something called u substitution, which is kind of backwards to what we're doing now. That's why we used it. Try this one on your own. See how you do. And then come back and check your answer. So if we take a look at this, substitute u in there. And so the derivative is just negative sine. Derivative of cosine is negative sine of u. Then multiply by the derivative of u, which is u prime. Define u prime, find the derivative of sine, which is just cosine, and then plug in, resubstitute u as sine of x, and then u prime is cosine of x. Look to see if you can simplify it, and in this case, you cannot simplify it, so that's as far as you can go with this one. Alright, so hopefully you did good on that. Let's do another example. There's 2 more examples, I believe. Again, on this one's a little different because if you look at this, you have a couple things going on. You have this function times this function, so you have to use the product rule. Okay, so you would have your s which can be either one of them. We'll use x to the third, and then your p is the 2x minus 5 to the fourth. So the derivative here is simple. It's going to be 3x squared. However, the derivative of p is a little less simple because you would have your u inside. So this would be like u to the fourth. And so the derivative is going to be, the derivative u to the fourth is 4u to the third times u prime, where u is the 2x minus 5, and then the derivative of u is just 2. And so then we continue that, resubstitute in your u, which is 2x minus 5 times 2. And so then the derivative here is going to be 8 times the quantity of 2x minus 5 cubed. Okay, and so now you can use your rule. So what you're going to do is you're going to take this times this, and then that times that, and then you're good to go. And when you do that, so y prime is going to be x to the third times 2x minus 5 to the fourth plus 3x squared times 8 times the quantity of 2x minus 5 to the third. If we go through and simplify this as far as we can, wait, looking at this, hold on. I multiplied some things together that shouldn't have been multiplied together, so let's get rid of those. Start over. So x to the third, I even color coordinated and I still messed up. I'm sure you guys caught that. Times 8 times the quantity of 2x minus 5 to the third plus 3x squared times, there we go, this looks a lot better. Then we can simplify this as 8x to the third times the quantity of 2x. I know it seems like a lot of writing, folks, but the more that you write, the better off that you are, trust me. The less likely it is that there's going to be any errors. So then this is just 3x squared times the quantity of 2x minus 5 to the fourth. And then that right here would be our final answer. And there is one more problem, and this is where what's called the power chain rule comes to effect, because you notice you're going to have to use the chain rule twice. Okay? So we can use u. If we rewrite this, it's going to be y is equal to u squared, when u is 1 plus the cosine of 2x. Okay. However, you can't find the derivative of this, so you have to rewrite u, and I just used a different variable. So let's use g for fun. And g then is 2x. So we start from the right and work left. So the derivative of g is just 2. The derivative of u is 1. Whoops, that 1 is gone. So the derivative of u is just negative sine of g times g prime. And we know g prime is 2. So let's substitute all that in, negative sine. And the g is 2x times 2, and we can rewrite that. Again, this is a lot of writing, but it's helpful to write as much as you can. It doesn't take much extra time. So now we have u prime, and then if we go back to y, I'm going to need some room. The derivative of y, so that's y prime, is 2u times u prime. Now we can substitute all that in. 2, and then u is the 1 plus the cosine of 2x. And then times u prime, which is negative 2 sine, I'm running out of room, like that. So then if we rewrite this, you notice that you can multiply these 2's together, so you get negative 4 times the quantity of, whoops, let's put that together too. Here, hold on. negative 4 times the sine of 2x times the quantity of 1 plus cosine of 2x. The only reason you would need to multiply that in is if it's multiple choice. But if it's free response, actually if it's free response, you can just leave it like that and that would be a right answer, correct answer. Okay, but chances are this is going to be an option on the multiple choice. So just be used to reducing them down, simplifying them down as far as possible. All right, so then that's the power chain rule when you have one inside of another. So just to review in this set of notes, our goal, our objective, our standard is to be able to find the derivative of these composite functions. Okay, whereas before if it was just sine of x, the derivative of sine of x is cosine. And then the derivative of x, which is your inside function, was always 1. So we didn't necessarily have to do it if your inside part was just x. But now, if it's cosine or sine of x squared, then that's when you need to use the chain rule.